Okay, this video will go over doing some normal distribution calculations using the calculator. And it's pretty much a faster way instead of having to rely on finding z-scores and using the table. And those are important for certain situations, but a lot of problems you can really just avoid that whole process unless you specifically need a z-score, or again, once you get a little farther into statistics courses, you're going to want to know those a little bit more detail on them, but a lot of stuff pretty much can be done with two simple things on the calculator. There's a normal CDF, which is going to stand for a cumulative density function, which will find an area, like a cumulative area in between two intervals or in between two values. So if you're given values and you want to find, what's the proportion of values that are in between there, or what the probability that a value is in a certain interval, we'll use normal CDF. And then the other one is if you want to find an actual value. So you'll be given an area, or you'll be given a percentage, or a percentile, and you'll need to find an actual value, like a raw score from the actual units that the data is in. Okay, so let's get a few examples, and we'll walk through the calculator process too. So for this example, I'm going to be using the number of minutes spent on, I should say spent with a T, on social media daily by a high school student is approximately normal, with a mean of 120 and standard deviation of 35. And I just made these up. I have no clue if they're accurate or not, but let's go with it. So let's say we want to get started. We want to draw the curve just to get kind of an idea of what's going on here. Okay, so we're going to draw ourselves a nice little normal curve. Try and do nice and symmetric. Center, we're going to go out 3 standard deviations. And we're going to plug in a bunch of values and just use that as a guide. Okay, so we always start with just putting the mean right in the center. So they're telling us 120 minutes is the average, and then we're simply going to add a standard deviation, which is 35 minutes. So we'll get up to 155, 190, and then 225. Okay, and if we're subtracting 35, we should be down to 85, 50, and 15. Okay, so that's going to be our basic spread of the data here. Okay, and then there are also some percentages. Basically, as soon as you are given the fact, or you see the word normal in a problem, that's going to be your key that these percentages I'm about to show you are always going to be the same. So basically, the curve gets divided up into certain intervals, okay, using those standard deviations as the width of the intervals. And then based on, there's these rules that say about 68% of the data is within one standard deviation. So 68 evenly split up gives me 34 here, 34 here. And then kind of walking through, there's a rule that says 95% would be 2 standard deviations. So if you kind of do the math and split out the remaining of the 95%, these 4 values now would contain 90% of all values, and then so on. So these again are numbers that never change, and these are the things I'm saying you don't really even need to necessarily memorize these because your calculator can do all this stuff for you, but I'm just doing this so we just kind of have an idea of how everything ties together. Okay, so those are your numbers. This is known as the empirical rule, so it's important, but again, let's let our calculator kind of do some work for us. All right, so question A, what percent of high school students spend more than 150 minutes on social media? Okay, so looking at our picture here, since 150 is not one of the numbers, I can kind of see 150 would be, somewhere in that area. I cannot simply just add percentages, but even if it was, even if this question was about 150 minutes, the calculator is still going to be much faster. So what we're going to do is we're going to think about, for this problem, 150 minutes and up. So let me see if I can draw this in here without destroying it. Is basically going to be all that area. Okay, we want to add that all together. Now the best way to do this, they gave you an actual value, and they want you to find a percentage. Okay, so that's going to be when you're using the normal CDF. I want to find the cumulative area that's from 150 minutes and up. Okay, so your boundaries, when you go on your calculator, we're going to go into normal CDF, so it's second distribution. Okay, there's normal CDF. Don't use the PDF, the first one. That's more for just if you were graphing the function, which you really probably won't ever have to do. Normal CDF though, and again, I want to go from a lower limit of 150. Now an upper limit, you just want to pick some really big number because there was no, it wasn't saying like 150 to 170 or like there was no stopping point. It's just higher than 150. So I usually just go with like this 9999 or 1,000 or a million or just use some big number. It really won't change your answer all that much at all. And then the mean and standard deviation are the next two, and those were given to us again as the 120 and the 35. 120 and 35 for mean and standard deviation. Okay, if you happen to have a little bit older software on your calculator, you're gonna have to enter it in like this. After you type the 150, you need to use the comma, which is right above the 7. And you're just separating all these values with commas. And what this is gonna do, it's gonna give you a percentage, or that's actually a proportion out of 1, which we could convert to a percentage as 19.6%. Okay, and that's gonna be our answer for this first one. What percent? So just to fill in what we did 150 for a lower, we did upper of 9999, we did a mean and a standard deviation, and we got right around 19.6%. Okay, so that's exactly what normal CDF does. It's going to find you the percentage of values within a certain interval. Okay, so moving along, how many minutes are the top 10%? So again, think about this. If we have this curve, I'm just going to draw a real brief version of the sketch. I know the mean was 120. Okay, now this time they're giving us a percentage to use. Our answer to this is going to be a value. It's going to be a number of minutes. Okay, so we need to think about the top 10% might be up here somewhere, okay, where there's 10% of the values up there. Okay, and our job is to figure out how many minutes would that be. So since we're not finding a percentage, we were given a percentage, we're finding a raw score. We're going to use the inverse normal. It's the other command on the calculator. And the way that it's set up is you're going to input 3 values. The second and third value are, again, the mean and the standard deviation. So same as before. Now the first value that you enter is always the area below or to the left. So sometimes we need to think about how much area would there be to the left of this value. So we got to do a little thinking. If they told us there's 10% above the value, that means there must be 90% below. So these must always go in as a decimal. They're treating them out a proportion out of 1, not necessarily as a percentage out of 100. So 90% would be 0.9. And we can do that in the calculator as well. Same menu, second vars. There's an inverse normal. Okay, the newer calculators actually tell you what you need. So it's 0.9. We had a 120 mean and we had a 35 standard deviation. Okay, again, we paste that. The old calculators, you're going to have to use the commas again to separate them. And that's going to give you now, that number is that's a number of minutes. 164.9 minutes if we round that. Okay, so that's what we're looking for here, is 164.9 minutes. Again, that would be the value that would be sitting right there. Okay, so that's the difference. We were finding a value, not a percentage. That's why we used inverse. All right, another one. Let's say you were told that you rank at the 35th percentile. How many minutes do you spend? So we're trying to find a number of minutes again. We're going to use an inverse norm. Okay, we're not trying to find a percentage. They gave us basically a percentage. So just got to know here, percentile means the percentage of values that are below your value. So if the mean is there, there's some value right here which we're trying to find that would contain 35% of the data beneath it. Okay, so when they give you a percentile, that's going to be your first number in here. That's the area below. And we're going to put in the mean and standard deviation, same as it's always been here. And we're going to get a value now, and that value is going to be the 35th percentile. Okay, so let's do that real quick. Second distribution, we have an inverse norm. Our area in this case, it's always area to the left. So percentile was 35. And we're going to get a value of 106. So just over 106 and a half minutes. Okay, so 106.5. Okay, let's see what else we got going on here. Look at that screen shade. I don't know what happened there. students. All right, so part E. All right, if there are 100, or I'm sorry, if there are 400 students in the school, about how many would spend between 1 and 2 hours? Okay, so they did not give us, or they didn't give us a percentage here. Okay, we're not using inverse norm. They actually gave me units that are similar to what the actual raw numbers are, which are amount of time. In this case, they gave us hours, but we can convert those. I know 1 hour is 60 minutes, 2 hours is 120 minutes. So they're basically first asking us for, again, the mean was 120. They want to know, first off, what percentage of all people were between 60 minutes and 120 minutes. We'll find a percentage using the NormalCDF now. Okay, we're finding a cumulative area, right? NormalCDF between 60 minutes, 120 minutes. If the mean's 120 and the standard deviation's 35. So this is going to tell me what percentage of area is shaded there. And then what I'm going to do is I'm just going to take that percentage out of 400 students to get a final answer. So this one just had a little wrinkle in it, but it's still basically asking for about the number of students, and it's not asking about finding a value in minutes. They gave us those numbers. So let's do the NormalCDF part first. So we're going to go from 60 to 120. The mean and standard deviation are still the same, 120 and 35. Okay, and that's going to give me 45.7% we'll go with. Okay, so 45.7%. And now if this question just said what percent of students are in that range, that's what we would go with. But this one again had that little twist to it. It's saying if there were 400 students, so we really need 45.7% of 400. So you can always just multiply 0.457 times 400, and this should be around 182 or 183 students. Okay, so it's, I mean, it's a little less than the 400 students, which seems reasonable, 45%, a little less than half. Okay, so that's what we're looking for part E. All right, part F, what range of values, okay, so we're trying to find values given a percentage, okay, we're given the percentage. We're going to use an inverse norm here. Okay, so let's draw a little picture. I'm going to do it on the next page, a little more space here. So we need the middle 50%, right? So let's say, here's our curve. Okay, 120 is in the center. Okay, there's some numbers here and here that would contain 50% of the values. Okay, and we need to figure out that number and that number. So we're going to do two separate problems. Okay, let's find this one first. So again, we're finding a value. So we're doing an inverse norm. Okay, what area is to the left of that value? So let's think about it. If we have in the middle here, we have 50%, right? From here to here, it's 50%. So you got to use a couple of properties here. I know the total's got to be 100%. And I know these are symmetric. So the remaining 50% is evenly split up between those two outer regions, or those tails are what they're called. So each one of those would have to be 25% to keep everything symmetric on both sides and add up to 100. So the area to the left of this point is 25%, okay, again as a decimal. Mean and standard deviation are still given, so that one, I'll just do it real quick. I got a calculator here. Inverse norm, if we do 0.25 with a mean of 120, I'm getting a value of 96.4. Okay, again, that's minutes. Okay, now to find this value, we'll do a separate inverse norm. Okay, now how much area is to the left of that one? So from here, if I add up everything to the left, I have the 50% in the middle plus the 25. So I have 75% of the area below. Okay, and this will give me that upper limit there of 143.6 minutes. So those are the two values that would contain the middle 50% of all student values. Okay, so that was using inverse normal twice. All right, and then lastly, let's see, there's one more problem I wanted to talk about. We gave that one. All right, here's a good one. All right, let's say scores on a final exam are approximately a normal distribution. The mean is 80. Okay, so let's just start. Let's see what we got here. So we got a curve. These are all the scores. The mean is 80. Okay, so you scored an 85, and you were told you were at the 77th percentile. And we need to know the standard deviation. Okay, so let's put this out. So your score was an 85. To kind of get an idea of where it would be, 77th percentile is above half, so it's going to be somewhere above the mean up here. I'm just estimating. So an 85, now think about what percentile, again, tells you is the percentage of values beneath your value. Okay, so I know from this 85, all of this down here is 77%. Okay. Okay, and not that we necessarily need that, but then that would kind of indirectly tell me that there's 23% of the values above. So we don't have to use that, but just so you can kind of put it all together. Okay, so what we need to figure out is what is the standard deviation. Okay, so we know the mean is 80. Standard deviation we want to try and find. They gave us an actual individual score of 85. So what comes to mind here when you start seeing all this stuff, there's a formula, there's a z-score. Here's where knowing your z-scores would help you. A z-score is always the actual value minus the mean over the standard deviation. Okay, we know the mean and we know the actual value. The thing we don't know is actually just right here. So if we can somehow find the z-score for our value, we can then write ourselves an algebra equation. So the idea is you can use an inverse norm. Let's say we treat 80 as really a z of 0, right? It's the mean. The mean z-score is always 0. So what I'm going to do is use inverse norm, and I know the area below. So the z-score for an 80, for a score, I want to write that there. It might mean something else. The z-score will be an inverse norm. Okay, the area below the value is 77%. Now the trick, since we're thinking about z-scores, is the mean is 0, the standard deviation is 1. Okay, doing this calculation, 0 and 1, gives me a z-score of 0.7388. Okay, so that tells me, excuse me, my score, the score of 85, was 0.7388 standard deviations above the mean. Okay, so I wasn't quite to a full standard deviation. I was, 3/4 of the way. But what it's going to let us do is plug everything in now to this equation, and there should only be one unknown piece there. So the z is what we just found. I know that equals the x, which is the value. So value is 85 minus the mean, which is 80, over some unknown standard deviation. Okay, so we have ourselves a little algebra equation. I would multiply both sides by the standard deviation, get it out of the denominator there. Okay, of course 85 minus 80 is just 5. And if we divide both sides by the 0.7388, we get our answer. Sigma is around 6.77 approximately. That would be the standard deviation that would make all this work. Okay, so hopefully that helped. Again, make sure you're comfortable with the calculator. The two different commands, there's really only two that we're going to be using here, and it's all about what you're given, okay, and what it finds. So if you're given an interval, okay, or you want to find a percentage that's greater than or less than or within some interval, you're going to use NormalCDF. Okay, if you are trying to find an actual value from the data distribution, you can use inverse normal. Okay, if you're given the area, given a percentage, you want to try and find a value. Okay, so just practice a little bit on the two, and that should make it a lot easier and kind of avoid the need to really do too much with the z table at this point.